Hey there, welcome back to the channel. Next up in our series of building our fan controller, so we have to make this microcontroller drive this automotive relay. Let's get to it. The primary challenge we have here is we want to drive this relay with this microcontroller. The coil on this relay, which is from here to here, requires it's a 12-volt relay, but the requirement is probably about 7 volts minimum in order to activate this. This microcontroller, and in fact pretty much all microcontrollers, will put out typically 3.3 and or 5 volts. This does not have enough voltage to drive it, and in fact the power output from this would consume most of the budget. So we couldn't do much else if we're driving one of these. What we need to do is build a driver circuit. So we need to drive something that then turns this on and off. We're going to do that with a transistor, a resistor, and a diode. Let's go over and take a look at the circuit. This is what our driver circuit will look like. This is the relay here. We're going to provide it, I say 14 volts here because when running, a vehicle usually puts out about 14 volts. It comes into this coil through the relay, and then we have our transistor, which is effectively our switch, and then down to ground. We're going to drive this transistor as a switch from our microcontroller, the D00 output. We're going to go through a resistor so it isn't pulling a whole lot of power. And then here we have a diode. This is a flyback. When this opens and closes, there is electrical current that is pushing through there, and it gives it a path when this closes, actually I guess when it opens, for the power to go back. Then over here are our outputs. We've got our power input. This would actually come from the 14 volts as well. And then we have a normally closed, so it's always on until the relay activates, and then normally open, which is what we will be using for our fan. Now let's go over to fritzing and do a diagram so we can see what this is going to look like on our breadboard. Here I've built a fritzing diagram for this. It's not exactly what we have, but it's good enough for the demonstration. So we have our battery here. This would be the vehicle battery, so 12 to 14 volts. Power comes in here, comes in, the diode's connected to it here, goes through the coil, through this relay, back out of the relay, and then it comes into the collector on this transistor. So this transistor acts as a switch. It comes out the emitter on it, and then just goes back to ground and over to the battery. So the base, which is this middle pin, that is the thing that activates it. We're going to drive it from our D0 on our meadow through this 2.2K ohm resistor. So out of the D0 through a 2.2K and into the base of this that acts as the switch. Pretty straightforward, pretty simple. Let's go put this together on the breadboard. Here on the breadboard, it's a little bit more complex because I still have the temperature sensor here hooked up and I don't want to disconnect it. But what we have is over here, I have power coming in from a bench power supply. Here, have it set to 14 volts. It comes in here, comes over this white wire, comes over to the diode, then out this purple wire, over to one side of the coil, out of the other side of the coil, back to here. Then it comes through to the leg of the resistor. So that goes to our collector. And then our emitter on the other side comes out, goes to ground. You can see this is the ground and power for the meadow. So this is 3.3 here, and this is 14 volts. I've coupled the grounds together. That's important that they have a common ground. Then for the base, got this blue wire, comes out of D0 over, connects to this resistor, which comes over and connects to the base of this transistor. All right, let's go write some code, make sure this works. The code for driving this relay with a meadow is trivially easy. You can see we just create an output, which is a digital output port on pin D00, and then I just go into a loop. We change the state from off to on and back again, and we just set the output state to that new value every 2 seconds. As we move forward, I will create a relay class and wrap this in something that makes a little bit more sense from a system perspective, but functionality-wise, that's all there is to it. Let's deploy this application down to the device and make sure that the relay runs. All right, the code's deploying. The app is starting up. And you can hear it turning on and off every 2 seconds. If we take a look here, this is the current that this power supply is providing. So there's on, there's off. So when it's on, it looks like it's taking about 140 to 150 milliamps to drive that coil. That transistor has a rating for 600 milliamps, so should be just fine. That's all there is to it for this part of the video. Next up, we'll be connecting this temperature sensor to drive this relay. That'll be in the next video. Go ahead and subscribe if you'd like to get notified when that happens. Thanks for watching.